Now we are going to apply solving acid-base equilibria. Remember the last chapter we did? We used to solve all equilibrium exercises using a technique called the ICE or the RICE table. R stands for reaction. So we are going to write the reaction, the dissociation reaction of hydrosulfuric acid. Next, I, initial concentrations. We are given that the initial concentration of the hydrosulfuric acid is 10. Next, C, the change in the concentration. As the reaction proceeds, the concentration of H2S is going to decrease by a certain amount, and the concentrations of HS- and H3O+ are going to increase by the same amount. This is because 1 mole produces 1 mole and 1 mole. Finally, E, which refers to equilibrium concentrations. To calculate E, all we have to do is add the columns. So we have 10 minus X, X, and X. Next, we are going to write the dissociation of an acid expression. It is the concentration of the H3O+ multiplied by the concentration of HS-, which are our products, divided by the concentration of H2S. We are given Ka, 1.7 times 10 to the minus 7. H3O+ concentration is X, and so is HS- concentration. Concentration of H2S is 10 minus X. We end up with a quadratic equation. To make life easier, and since we already know that hydrosulfuric acid is a weak acid, then we can make an assumption that the value of X, which is the equilibrium concentration of the H3O+, is going to be a number much smaller than 10. In that case, we can say that 10 minus X is actually equal to 10, neglecting the X. Therefore, we end up with X squared being equal to 1.00 times 10 to the minus 6, which means that X, which is the concentration of H3O+, is equal to the square root of 1.00 times 10 to the minus 6, which is equal to 1.00 times 10 to the minus 3. What we are required to calculate is the pH. pH is the negative log of the concentration of H3O+. So it is the negative log of 1.00 times 10 to the minus 3, which is equal to minus 3, 3.00.